All right, section 11.3, take 2, the first time if you happen to watch it. Halfway through the video, I refocused on something close, and it never refocused back on here, so half the video was blurry. If you didn't notice that as you watched the entire thing, maybe it was your own head that was fuzzy through stats. Lame joke. Sorry about that. Here, section 11.3, inference about two means with independent samples. So in this case, our idea is not the matched pair. We're not looking at the differences between two samples that were taken resulting in a single sample of differences, but here we're just looking at two samples of things. One of the things that I tried to do earlier and ran into a wall with degrees of freedom was a quarter example. We have a handful of state quarters, a handful of traditional quarters. I think we mentioned that in a previous video. So you've got this. Do the state quarters weigh more than traditional? I don't know. Let's take a sample of state quarters, a sample of traditional quarters, and see if one weighs more than the other. It's small samples. It is not proportions. We don't know the overall population, standard deviations. All of that says t-test. And that's what we have to do here. The problem comes in with when we're looking for the critical values, the fences. Because it's t, it's based on degrees of freedom, and there are multiple ways of determining the degrees of freedom on these. The book has two methods, maybe three. The internet has three. The StatCrunch uses one, depending if it's pooled or not. It's kind of a mess. My suggestion, as I looked over the homework, trust in the probability method of things, the probability logic of this. Compare the probability to the alpha. Don't buy, and I don't think the homework even suggests that you compute the fences to make a comparison. As I was working through the quarter example, I actually found, using one of the ways to calculate degrees of freedom, I found a fence that I believe it made us reject the null, but the probability said don't reject the null. And that's what just gave me all kinds of craziness. So suffice it to say, we're going to trust what the degrees of freedom as they show up in the StatCrunch, and we're going to use the probability method of things. So that's what we have to work with. So I think I talked about this. I talked about this. Talked about this. Talked about this. Students' t-distribution. So let's go into this example. A researcher with the Department of Education followed a cohort of students who graduated from high school in 1992, monitoring the progress the students made toward completing a bachelor's degree, a 4-year degree. The data is shown in the following table. At a 1% level of significance, does it take longer to graduate if you transfer from a community college? I don't know. Let's see what the data says, and let's see if the data is statistically significant enough for us to make a determination if the difference is simply that's the way the samples worked, or there is a substantial difference. So if we look at this, we can see we've got a couple of samples, large sample sizes, right? Which takes us to our degree of freedom. One theory is you take the lesser of the sample sizes and subtract one. Another one says you add the two together and subtract two. And a third one that I really want to show you, and I'll make sure that I refocus the camera so it's not blurry. The third one, let's see if you can read that. Yeah, that's the third way of computing the degrees of freedom, which is just a mess, right? But interestingly, that is what, is this focused? Yeah. That is what StatCrunch uses, that crazy formula, because it's just a formula. StatCrunch can do that beautifully. But every one of those different degrees of freedom is going to give you a different fence, a different critical value. But the probability is always going to be the same. So that's kind of a refreshing thing, a comforting thing. All right, so those are our two samples. These students went directly from high school to the 4-year institution. They took 4.43 years on average. This group of students went to a community college first and then a four-year institution, and their total of community college and four-year institution was 5.43. Looks like a whole year difference, right? Which kind of seems, with these small numbers, that's got to be significant, right? You'd think that would be statistically significant. Let's see, the standard deviation is about 1 year different. So what we'll do is we'll go through our whole steps. We've got 5 different tests. These are from chapter 10, you recall. This is from chapter 11. 1. This was 11.2. This is now 11.3. Please, again, note the difference between a t-test and 2 independent means t-test, a 2-sample t-test. And this is going to be a right tail. Why is it going to be right tail? Because we're defining it as transfer and directly to. So if you've got these two, the transfer and the directly to the four-year institution, we think that this one might be longer. So if this one is longer in that order, if you subtract them, longer minus shorter, you're going to get something positive, greater than 0. Greater is a right tail test. So we can process through that. Give yourself some patience as you work through these questions. Sometimes it takes 35, 40, 45, a minute to really work through and figure out what are they really asking. And you've discovered that as you've gone. Level of significance is, again, 1%. The critical values, yep, that's the critical value that we have, the smaller of them, -1. I took this from the book and looked at the answers in the back to confirm that that was the method that they were using for this question, and that's what they did right here. And the table only goes up to, let's see, it goes to 100, then to 1,000. This was the closest one we had. But you'll see, the degrees of freedom is 267. That's what we computed our fence with. You'll see how StatCrunch does it in a second. And speaking of StatCrunch, you go to a 2-sample T. Find that in the calculators. At this point, you know how to find those. Just make sure that you have a screen that allows you to do a sample 1 with the data, with the summary statistics, and sample 2. We're going to do a hypothesis test with either equal to 0 or greater than 0. And then we're going to make sure that we draw something as well. And check out the degrees of freedom using that formula way higher than the 267 that it showed. But check out the statistic, the T statistic. Usually we expect things, 1, 2, maybe 3. This is 12. 12.9772. This thing is off the charts. In other words, there's no way that the data we collected shows that it's an equal amount of time. It's going to take more time. We're clearly going to reject the null hypothesis that says, yeah, it takes about the same amount of time to get a four-year degree if you go through a community college first. No way. The probability is less than 0.0001% chance that it's that they are the same. Okay, so that's we'll write those down. We see those and we can enter those in beautifully. What does that mean? Well, it's clearly outside the boundary, no matter what boundary we found, and the p-value is clearly less than alpha. So we're going to reject. There is statistically significant evidence to reject, so we should. What is the conclusion? There is evidence to suggest that students who transfer for community college take longer to get a four-year degree. Interestingly, so what, right? Does that mean that if you're just really